Engineering Tech Tutor, and today we're talking about states of material. Materials have three states. They are solid, liquid and gas. Now to change between these states we have to add or remove heat. So to go from a solid to a liquid, all I have to do is take the solid and heat it up. I can then take my liquid and apply more heat and turn it into a gas. Equally, if I want to turn my gas back into a liquid, all I have to do is cool it down. And again, if I take my liquid and I cool it down even further, I can turn it back into a solid. Okay, so before we can talk about states of materials, we actually need to talk about the material. So a material looks to be solid to us, but actually, if you look at it under a microscope, you'll find it's actually made of small items called atoms, particles, or molecules, depending on what material you're looking at. Now we can't see these with our eye, we have to use a microscope to see them. And I don't have a microscope to show you, but in this picture here I have an orange cube. Now if I imagine I was looking at this cube under the microscope, what I would see is this block made up of lots of circles, all tightly pressed together. It is the way in which these particles are held together that determines the difference between a solid, a liquid and a gas. Okay, so let's talk about solids. Let's bring the solid back on the screen from the previous page. In solids, the particles are held very closely together, and because the forces between the particles are very strong, the particles cannot move around. This means that solids have a fixed shape and volume, because the particles cannot move to allow the shape to change. The only way to change the shape of a solid is to hit it or to cut it. So let's talk about how these things happen. Let's take our solid again, and this time we're going to push down with a knife and try and cut the thing in two. Now the sharp edge of the knife will push down against the particles, and as it does so it will overcome the forces that hold the particles together and allow the two pieces to come apart. Equally, if I take another solid and this time I try and hit it with a hammer, the force of the impact is so great that it pushes the particles away from each other and overcomes the forces that hold them together. And the final thing to know about solids is that you cannot compress them. Because the particles are so closely pressed together, there's nowhere for them to move, and so you cannot make the shape any smaller by pressing it together. The next state we're going to talk about are liquids. Now liquids are very similar to solids, but the difference is that the particles can move around relative to each other. Now let's talk about why this can happen. The particles are held together with the forces that we spoke about before. But as I heat up a material, the particles start to get warm and they start to move and vibrate. And because they are vibrating, it's not easy for them to stay in position, and the forces that hold them together are slightly overcome. Like a solid, a liquid cannot be compressed because the atoms and particles are still closely pressed together and already touching. So let's apply some heat to the material on the screen and turn it from a solid into a liquid. As the particles have heated up, they have started to move and vibrate, and the forces have been overcome such that the particles can move away from each other, and gravity takes over and they fall to the bottom of the container. Because the forces in liquids are overcome so easily, liquids do not have a fixed shape. They spill it out to fill the container they are stored in. Liquids, like solids, cannot be compressed because the particles are already very closely packed. The third state we're going to talk about today are gas. Gases are actually quite like liquids, except they can be compressed. Now you'll remember that liquids don't have a fixed shape because they can spill out to fill up the container they're in, and gases are the same, except the big difference is that gases don't have a fixed volume. Now let's take our liquid that we used on the previous page. If I apply more heat, the particles start to vibrate more and more. They get to the point where the vibrations are so extreme they break away from each other and move apart. And with nothing to stop them moving away, they will continue to move until they hit another boundary, such as the jar they're sitting in. This means if you do not put a lid on a jar and fill it with a gas, the gas will escape and you will lose it. The thing to remember about gases is because the particles are so far away, if you were to squeeze them and compress them, you'll find that the particles will move back together again. This means you can take a gas in a very large volume and squeeze it until it is compressed to a much lower volume. So let's see if we can do a demonstration of the things we've just been speaking about. I'm going to take ice and I'm going to see if I can turn it into a liquid and a gas. I'm going to do that by adding heat, because we know that adding a heat turns a solid into a liquid and a liquid into a gas. So let's start by taking ice and turning it into its liquid state, known as water. To do that, I'm going to need some ice cubes, a time-lapse camera, and I think it's probably about time to cue the montage music. Oh no, I didn't think that through, did I? I don't have any ice. Wait a minute, I can take liquid, I can cool it down and make it a solid. Right, re-cue the montage music, we need to make some ice. First thing is that the ice was able to turn to water when it was left in a room at about 18 degrees centigrade. But it took about 2 hours, and there certainly wasn't enough heat in the room to turn the water into steam. So if we're going to turn it into steam, we need to apply much more heat. But let's try that again, but this time we use a lot more heat to accelerate the process. Now this time we put the ice cube on a very hot surface. This saucepan is on a stove with gas fire underneath it. Because of the heat involved, this should only be attempted by an adult or with adult supervision. Because the ice is placed on a very hot surface, it starts to melt almost immediately and turns to water. Before long, all the ice has turned to water and the water has started to get hot. On the right hand side of the pan you can see bubbles are forming. This is because the water is getting very hot and is now turning into a gas or steam. The gas is formed at the bottom where the water is touching the pan, and it rises up in the form of bubbles until it reaches the surface. This continues until the water is fully boiling at 100 degrees centigrade. As the water turns to a gas, the gas expands to fill the volume of the container. In this case, the saucepan does not have a lid, and so the gas escapes out into the room. This means the water level reduces and reduces until eventually there is nothing left.